Well, hello there. Here we are with chapter 2, lesson number 8, inverse trig functions. Now, something we have been doing in the past and we have seen in this chapter is we've been able to differentiate our 6 basic trig functions: sin x, cos x, tan x, sec x, cosec x, and cot x. However, let's take that a stage further. What we can also do is we can differentiate inverse trig functions. Yeah! So, 3 of which we will look at in advanced higher maths. So the 3 we can differentiate are sin to the minus 1 of x, cos to the minus 1 of x, and tan to the minus 1 of x. So these are given on the formula sheet, and what we need to do is know how to use them. So if we have f of x, we can differentiate that to get f dash x. So if we have sin to the minus 1 of x, if you differentiate that, you get 1 over the square root of 1 minus x squared. If you differentiate cos to the minus 1 of x, you get negative 1 over the square root of 1 minus x squared. And if you have tan to the minus 1 of x, that one's slightly different, you have 1 over 1 plus x squared. Let's try some examples then. Example 1, differentiate y equals sin to the minus 1 of 3x. So for this one, Sophie, what would you do? Good, you're thinking, right, well, it's sin to the minus 1, so if I differentiate that, I get 1 over the square root of 1 minus x squared. However, with this, you've not got sin to the minus 1 of x, you've got sin to the minus 1 of 3x. So what you do in the derivative is you replace the x with 3x. So instead of x squared here, you'd have 3x squared. So we'd have 1 over the square root of 1 minus 3x all squared. Perfect. What you then have to do though, when you differentiate, you are going to have to remember to use the chain rule. So you multiply by the derivative of what's in the bracket. So if you differentiate 3x, you get 3. So you'd multiply that by 3. From there then, treat that as 3 over 1, multiply numerators, denominators, or just move the 3 to the top, and it gives you an answer then of 3 over the square root of 1 minus 9x squared, because you're multiplying the 3x squared by itself to get 9x squared. And that's what you would get. Example 2, differentiate y equals tan to the minus 1 of x squared. So for this one, you are thinking, right, well, I'm differentiating tan to the minus 1. It's the inverse trig function. And if I differentiate tan to the minus 1, I get 1 over 1 plus x squared. But again, instead of tan to the minus 1 of x, I've got tan to the minus 1 of x squared. So in the derivative, you replace the x with x squared. So you're going to have 1 over 1 plus, and instead of x squared, you'd have x squared squared. But then again, what do you need to remember, Ian? Good, you need to remember to multiply by the derivative of the x squared. And if you differentiate x squared, you get 2x. From there then, we'll move the 2x to the top, so it will give you an answer of 2x over 1 plus, and if you have x squared squared, then that would be x to the power of 4. So that's your answer. Example 3, differentiate y equals cos to the minus 1 of 1 minus 2x. For this one, Vera, what are you thinking? Good, you're thinking it's cos to the minus 1, so if I differentiate that, I get negative 1 over the square root of 1 minus x squared. But instead of cos to the minus 1 of x, I've got cos to the minus 1 of 1 minus 2x. So in here in the derivative, I replace the x with 1 minus 2x. So that would give me negative 1 over 1 minus the square root of 1 minus, and then in brackets 1 minus 2x squared. You're just replacing this x, as I said, with 1 minus 2x squared. But you've then to multiply by the derivative, and if you differentiate the bit in the brackets, 1 minus 2x would differentiate to give you negative 2. Perfect. From there then, you can move the negative 2 to the top, but because you've got a negative and a negative, really the 2 negatives would disappear, leaving you with 2 over the square root of 1 minus 2x squared, which is very messy, so we want to try and simplify that. How could you do it? Yeah, you could just multiply out the brackets. You've got something squared, so let's multiply out the brackets the way we've been doing for years. So leave the rest of it as it is. We'd have 2 over the square root of 1 minus, and if you multiply 1 minus 2x by 1 minus 2x, it'll give you 1 minus 4x plus 4x squared. From there, well, you could multiply out the brackets, so you'd have 1 take away 1, you'd have take away the negative 4x, which will give you plus 4x, and then you'd have take away the 4x squared. But because you'd have 1 take away 1, well, that would disappear, leaving you with 2 over the square root of 4x minus 4x squared. Could you take that any further, Megan? Yes, you can, because you could take out 4 here at the bottom as a common factor. You could take out the 4x, but if you took out 4x, well, then you'd be stuck. You couldn't do anything. Why are you just taking out the 4, Megan? Yeah, because you could work out the square root of 4. It's under the root sign. So, you're perfectly right. That would go to 2 over the square root of 4 bracket x minus x squared. The reason Megan did not take out the x as well is because she's now got it with the square root of 4. And we all know what the square root of 4 is. And because you've got the square root of something times something, you could split that up. So it's 2 over the square root of 4 times the square root of the 1 minus x squared. Well done, Megan. And then from there, well, the square root of 4 is 2, so you can replace that with 2. And then at the top, you've got a 2, and the bottom, you've got a 2. So if you divide them both by 2, or cancel them out, it would leave you with 1 over the square root of x minus x squared. And that's your answer. Example 4, differentiate y equals tan to the minus 1 of the square root of 4x minus 1. So for this one, again, we need to think it's an inverse trig function. We've got tan to the minus 1. If I differentiate tan to the minus 1, woo, I get 1 over 1 plus x squared, but I don't have x. I've got the square root of 4x take away 1. So in here, I replace the x with the square root of 4x take away 1. So that would give me 1 over 1 plus, and then as I said, you're replacing the x with this bit in the brackets. So you'd have the square root of 4x take away 1, and that would obviously be squared, because I've got x squared here at the bottom. What do you need to do then? Good, you multiply that by the derivative of the bit in the brackets. So you multiply by, if you differentiate with respect to x, the square root of 4x take away 1. It's just the chain rule that you are using. Further then, how would you differentiate the square root of 4x take away 1, Chasm? Yeah, you'd have to write that as 4x take away 1 to the power of a half. So I'm just going to write that as 4x take away 1 to the power of a half. Also, just over here on the left, if you have the square root and then squared, well, they will cancel out, leaving you with 1 plus, and then you've just got 4x take away 1. Really, from there, well, I suppose if you get rid of the brackets here, you'd have 1 plus 4x take away 1. So the 1 take away 1 would cancel out, leaving you with 1 over 4x. And if you differentiate 4x take away 1 to the power of a half, well, again, you're thinking chain rule. So bring the power down, so you'd have a half. Take 1 off the power, leave the brackets as they are. So you've got 4x take away 1 to the power of negative 1 half. But you're going to have to multiply by the derivative of what's in the brackets. We are using the chain rule again. Woo! More chain rule. So differentiate the 4x take away 1, you get 4, so you'd multiply by 4. From there, you just need to tidy up all of this. From there, you'd have the 1 over 4x times a half times the 4. Well, I suppose a half times 4 would give me 2. So it's really going to be 2 over 4x. And divide the top and the bottom by 2. It will give you 1 over 2x. And then from there, you'd have the 4x take away 1 to the power of negative a half. If you write that with a positive index, well, you could have 1 over 2x and move the 4x take away 1 to the negative half down to the bottom, so it would be positive a half. And because you've just got a half, well, you know that just means the square root. So that there will be your final answer. Example 5, differentiate f of x equals sine to the minus 1 of x over 3. So for this one, again, we're thinking it's an inverse trig function. I've got sine to the minus 1 of x, and if I differentiate that, I get 1 over the square root of 1 minus x squared. However, you can see that instead of an x, we've got x over 3. So in here, you would replace the x with x over 3. So that would give me 1 over the square root of 1 minus, and then you'd have x over 3, all squared. From there, though, remember you have to multiply by the derivative of what is in the bracket. So you're multiplying by the derivative of the x over 3. It's really just the chain rule. From there, to get the derivative of x over 3, how would you do that? Well, it's best to think of x over 3 a different way. If you're working that out, well, really, if you're dividing something by 3, Gary, what fraction of it are you taking? A third. Yeah, so really, x over 3 just means a third of x. So you want to differentiate a third of x. And if you have a number in front of x and you differentiate it, well, the x will disappear, leaving you with that number. So you just have 1/3. From there then, you would have 1 over the square root of 1 minus x squared over 9, because you're squaring the x and you're squaring the 3, so it's x squared over 9. And you'd multiply that just by 1/3. From there, well, this bit in the brackets, you need to try and simplify this. So we've got 1 minus x squared over 9. So I'm just going off to the side and I'm thinking, how else could I rewrite that? Well, the best way to do it is to probably put it together in one fraction. So 1 just now is treated as 1 over 1. To get the same denominator, well, I'd have to multiply the numerator and denominator, if you had 1 over 1, by 9. So really 1 is the same as 9 over 9. So it's 9 over 9, take away x squared over 9. From there, it's the same denominator, so you can subtract. You can do 9 take away x squared, and that would be over 9. If you rewrite that then, that'll be 1 over the square root of, and then you've got 9 minus x squared over 9. And then you're still multiplying by 1/3. From there, where could you go? Well, what you want to think is you've got the square root of 9 minus x squared over 9. And really, if I'm rooting the fraction, what you're doing is you're taking the square root of the top and the square root of the bottom. So the square root of the top, well, you would just leave because you don't know what the square root of 9 minus x squared is. But the square root of 9, you know, is 3. So you could write that as 9 minus x squared over 3. So that would give you 1 over, and just what you had there, the square root of 9 minus x squared over 3 times by 3. And then from there, well, really what you're doing is you're thinking, to work this out, you're multiplying the numerator, so 1 times 1, divided by, and then you've got multiplied these together as well. So the square root of 9 minus x squared over 3 times by 3. And to do that, well, think about that. You're dividing by 3 and you're timesing by 3, so that would cancel out, leaving you with the square root of 9 minus x squared. So that would just become 1 over the square root of 9 minus x squared. And that's your final answer. Example 6, differentiate y equals x squared sine to the minus 1 of x. For this one, Oliver, what are you thinking? Product rule! Perfect, why are you thinking product rule? Yes, you've got something in terms of x times something in terms of x, so you do have to think about the product rule. U dash v plus u v dash. Ooh. And from there, u is going to be x squared. V is going to be sine to the minus 1 of x. If you differentiate x squared with respect to x, it just gives you 2x. And if you differentiate sine to the minus 1 of x, well, it's on the formula sheet, it's given here, you'd have 1 over the square root of 1 minus x squared. Perfect. From there then, u dash v plus u v dash. U dash v is going to be 2x times sine to the minus 1 of x. And from there, you would add on u times v dash. So x squared times by this fraction. So x squared times the 1 over the square root of 1 minus x squared. And then from there, where could you go? Well, really, you've got x squared times this fraction, so just move the x squared to the top, or treat that as x squared over 1, multiply numerator and denominator, and you'd get 2x sine to the minus 1 of x plus x squared over the square root of 1 minus x squared. Boom! That's your answer. Last example, example 7, differentiate y equals the square root of 1 minus x squared cos to the minus 1 of x. For this one then, what are you thinking, Abby? Perfect. Yes, once again, you are going to have to be using the product rule. And we're using the product rule again because we've got a function in terms of x. We've got the square root of 1 minus x squared times by cos to the minus 1 of x. Abby, well spotted. Boom. High five. So for this product rule, u dash v plus uv dash is going to be u is the square root of 1 minus x squared. But before you differentiate that, you would write that as 1 minus x squared to the power of a half. And v is going to be cos to the minus 1 of x. U dash. So differentiate u. Well, you know, to do that, you'd bring the power down. So you'd have a half, keep the brackets as they are, and then take 1 off the power. So a half take away 1 is negative 1/2. What you need to do, though, is because you're using the chain rule, multiply that by the derivative of what's in the brackets. So we're multiplying that by negative 2x, because if you differentiate 1 minus x squared, you get negative 2x. From there, tidy that up a bit. You've got the 2 times a half, so that would just become 1. You've also got that negative, and you've got the x times by, and I suppose if you write that with a positive index, it would be 1 over 1 minus x squared to the power of a half, which is a square root. So it's going to give you negative x over the square root of 1 minus x squared. V dash, if you differentiate cos to the minus 1, again, that's on the formula sheet, but it would be negative 1 over the square root of 1 minus x squared. Just like that. From there then, product rule, u dash v plus u v dash is going to be u dash times v is going to be this fraction here, negative x over the square root of 1 minus x squared, times by v, so times that by cos to the minus 1 of x, and then would be adding on u times v dash. So we'd have the square root of 1 minus x squared multiplied by this fraction here, negative 1 over the square root of 1 minus x squared. And then from there, what would you get for your answer? Well, you've got negative, you've got x times by cos x to the negative 1. If you just think about this as a fraction, just put that as over 1. You'd have negative x times cos x to the power of negative 1, and that would be over, if you have the square root of 1 minus x squared times 1, it would just be the square root of 1 minus x squared. But then, what you've got is, you've got the negatives, so the plus would become a minus, and then you'd have the square root of 1 minus x squared divided by the square root of 1 minus x squared. And when you divide something by itself, well, that would just give you 1. So it's really just leaving this 1 here. The multiply and the divide would cancel out, leaving you with take away 1. And that's your answer. Try some of the questions in the workbook, page 30. Check your answers as you go. It's differentiating your inverse trig functions. Just remember to look at the formulas. They are given on the formula sheet, and they are also there in the workbook. Any problems? Let me know. Take your time, and just remember, look out if you need to use a product rule or the quotient rule. Best of luck.